Anyway, so here I have another ATX power supply in for repair. This is an AOpen power supply, AOpen branded power supply, though these are actually internally FSP power supplies, which are typically very good quality power supplies, and you don't often see them fail other than bad capacitors, because they live in office boxes and old family computers manufactured in 2004, 2005, maybe up to 2007, and that's the mid capacitor plague era. And this is, I don't think, one of them, so I don't expect this one to have any capacitor issues, but it doesn't work. You can tell it's an old power supply because it only has one SATA port. So what happens when you plug it in is we have our tester here plugged in the off position, and when I plug it in we have a nice red light. If I give it a signal to turn on, we get literally nothing. So there are many things that could be wrong. First, let's test the primary input capacitors by unplugging the power supply. And the LED stays on well over 10 seconds, which is what you would expect from a good quality power supply. So let's dig in. Okay, so here's the inside. Unfortunately, this passive power factor correction coil is soldered, so I cannot easily disconnect it. And yeah, on the inside we have an FSP branded chip. So if you look at here, you see FSP logo on the chip, so that's what I would expect. So on the secondary side we actually do see two bulged capacitors, but I don't think they will be the cause of our issue, because it doesn't even attempt to try to turn on. So what we're going to do is I'm going to disassemble the entire power supply and prepare it to function outside, so we can diagnose the thing. Okay, so our power supply is ready to be tested outside of the chassis. As you can see, it is an FSP power supply. So what I did is basically I removed the fan and I disconnected the two wires going to the mains input jack, and I disconnected the passive power factor correction coil and just jumped it. Yes, you can do that. The passive power factor correction, the power supply will work absolutely fine without a passive power factor correction coil. And you can in some cases do the exact same thing with an active power factor correction, but you kind of need to know a bit what you are doing. You can just bypass it completely without knowing what you are doing, because you might damage something. So now what I'm going to do is I'm going to just solder 2 wires to the input, so I can connect it to my small inverter so we can power the power supply up. Like this. And now in theory, when I connect it to our, make sure there is no metal shavings or anything, in theory, if I now connect it to my power supply tester, and I connect the input wires to the inverter, my power supply should light up. At least the 5-volt standby line should light up, because it is what was working before. And we have 5-volt standby. So first thing I'm going to do now is check whether or not our 5-volt standby is actually 5 volts, or is it oscillating and doing weird things, because that our power supply, our main controller chip, is actually powered by the 5-volt standby rail, and if the 5-volt standby rail isn't working properly, our chip will not be able to turn on. So 12 volts DC, we will measure between a purple and a black wire, and we have exactly 5.1 volts. So we know that 5-volt standby line is working just fine. So what can we rule out with that information? So we can rule out the input fuse, all of the input circuitry, our bridge rectifier, and our main filter capacitors, along with this entire circuit right here, which is basically our 5-volt standby. Without any part of this without any of these parts, we wouldn't have 5 volts. So even though I just said we can rule out these two main capacitors, we're going to do one more test. So we're going to turn, it is now powered, which isn't all that smart of me, but give it power again, and now we're going to measure. These two capacitors are in series. So on the input I should have about 300 volts. So if you're using mains voltage, you're going to measure AC right here. I'm measuring DC because this is my little inverter right here, just outside of your view, is generating very high frequency AC, which already goes to a bridge rectifier and a capacitor, and that's why I'm measuring a DC voltage on the input. You would measure AC if you were powering the power supply from the AC or the isolation transformer or the series bulb or whatever. So next part, we are going to have to look for our bridge rectifier, which is right here. So we want to measure, you want to measure about, in my country we have 230 volts AC, so I want to see 330 volts on the output of the bridge rectifier, which I do. Now just on the output of the bridge rectifier, there are these two big capacitors, and they are connected in series. So what I want to do is I want to see now whether or not the voltage across them, the two capacitors, is equal. So since we have 330 volts, I should see about 150 across each one. Okay, 167 and 171. That's within margin of error, and I would say that our primary filter is working just fine. Okay, so the next thing I want to check is I want to check whether or not our okay, this power supply is fairly annoying to work on because it keeps the charge forever. And unlike the power supply in the previous video that I was just shorting with a screwdriver, I kind of don't want to do that on this one because this power supply is a good quality power supply. So I have a light bulb here. Discharge. Okay, yeah, it's fading away. So 2 volts, 10 volts. We're good. So now what we want to do is we want to flip the power supply again, and we want to find our 2 main switchers. So you would typically find 3 transistors on this first heatsink. One of them might not be here, just like it isn't in my case, because it is internal to this chip right here. And this transistor or this chip right here is not interesting to us because this third transistor is what's generating 5 volt standby. And since we have 5 volt standby, it is not interesting to us. So these 2 transistors are what we actually want to test. We want to test whether or not there is a short circuit across them. They don't typically fail open unless they are visibly exploded, but so I just typically test whether or not there is short between any of pins, and if there isn't, I say that they are fine. So this is our first transistor, and we have a short across the first transistor, and the second one is fine. So since my multimeter isn't beeping, there is another way you can test for shorts. You can test with an ohm meter. I'm now in the 200 ohm range, and now since this other transistor is shorted, I will see 44 ohms, 43 ohms, and there is a 0.7 ohms between these 2 pins. So using an ohm meter for this task isn't ideal, but it can be done. So we want to take this transistor out now. Okay, so here are our 2 transistors, and give me some light. So now what we want to do is we want to figure out, first thing we are going to do is we are going to test them once again outside of the circuit, because there is a possibility that they are faulty, they appear faulty because there is a short somewhere else in the circuit that just looks like a faulty transistor. So we go to diode test. This one is open, and this one has 46 millivolts, which is, if you see under 100, if you ever see under 100 in a diode test, it means there is a short circuit. So in this case you won't see anything. If I turn the leads around, you will see about 500 or down to 300 is the, I'd say, minimum. If you see under 100, then you know for sure that there is a short circuit. In this case you have 46 here and 0 here, so this transistor is definitely faulty. Okay, so our next step will be to identify these two transistors. We want to see that whether or not whether they are BJT transistors or if they are MOSFETs. So the general rule is you look at the name and if you see 1300 something or SC, that will be a BJT transistor. And if you see two numbers N and then another two numbers, that will be a MOSFET. But you can also always make sure by looking up on Google. In this case, we see this is a 13009 which is a transistor. I know it is a BJT transistor because these are very common type of transistors. They are in a family of 1300X line, so there is a 13001, 13003, 13005, 13007 and 13009. This is the highest end model of this transistor. So so in this case, when you have one faulty transistor and one working transistor, you can replace just the faulty one, but it is generally recommended to replace both of them. Why? Because sometimes when one of them shorts out, the other one can switch in a short circuit and be kind of damaged, but not really, and it could fail prematurely. Or the other reason is just because they are working in half bridge. You want these two transistors to be as close to each other as possible. So if you're replacing one of them, you should replace the other one too. Okay, so here in another power supply, I found a 13007 transistor, which is a member of the same family, and I know that I can put these transistors in this power supply. Yes, these are lower, these are weaker than these two, but since this is only a 400-watt power supply, I think they will be just fine. What I want to check though is these transistors typically don't fail for no reason. They can sometimes fail because they got loose from the heatsink, thus one overheated and failed. They can fail due to overloading because sometimes someone wanted to throw in a high-end graphics card in his old family computer and slapped a Molex to 6-pin connector and absolutely cooked the power supply. Or there is a third thing. The signal driving the bases of these two transistors is not good. So typically what causes bad driving signal for these two transistors are these two little capacitors. You can identify them because they are always between the middle transformer and the two transistors, at least in half-bridge power supplies, and they are always two of the same capacitors. So I want to take those two out of the circuit and check their value using my component tester. Okay, so here are our two capacitors. They are by TPO and they are 2.2 microfarad, 50 volts. So let's get our component tester and slap one of them in. My battery is low. It is two. Yeah, this one is good. So ESR is quite low for this small of a capacitor, and capacity is a bit under, but I'd say that's decent. So let's test the other one. Shit. So yeah, they are about equal. The ESR is good, and the capacitance is a bit under, but acceptable for these small capacitors. All that's left to do is I will slap these transistors in, though annoyingly their legs are a bit too short, so I will try to find another transistors with longer legs and solder these two capacitors back in. I thought I was out, but miraculously I found these two actual D13009s, so they are exact replacements. So yeah, I'm going to slap these two in this power supply and put the two capacitors back in, and then we will see if it turns on. Yes, I am aware of the two faulty capacitors on the secondary side. I will replace those two, but typically these higher quality power supplies can work comfortably with a few bad capacitors. I'm not saying that you should leave them faulty, but they will work fine, meaning that they will work enough for me to test it before putting new capacitors back in. So yeah. Okay, so the transistors are in. Now comes the scary part of powering it on. The legs on one of them were really quite short, which is kind of dodgy of me, but yeah, let's see if it blows up. Put the power supply in frame, although it's limited by the... It's limited, so... And there it is. We have perfect 12 volts. Okay, so if I plug in a hard drive, here's a failing Seagate hard drive. I'm assuming it's going to turn off as soon as I plug it in. Yeah. The drive is cycling because it cannot maintain the power demands of this hard drive. My inverter is struggling and it cannot maintain the power demand of the hard drive. But yeah, the power supply appears to be functioning just fine. So if I turn it off, then on. Yeah, the fan ramps up to 100% when the power supply turns on. So to test whether or not the both transistors are working equally, I'm going to test the voltages on the two capacitors. So one is 126 and the other is 126. So they are balanced. So that means that both left and right transistors are working equally. If one was working more than the other one for whatever reason, there would be higher voltage on one capacitor than the other one, and that would indicate a problem. So more than likely this power supply exploded due to external load, because it appears to be functioning just fine. Okay, so in the end I couldn't find, those are free 10 volts 2200 microfarad capacitors, and there is actually a fourth one, but it is not bulgy, so oh, there is actually a fifth one too. So there are 5 in total, and 3 of them are bulgy. So I couldn't find any replacement, so I'm going to leave it like this for now, and I'm going to order some replacements, and put them in at a later date. So we can test the power supply like this. I actually do have a motherboard with a quite a demanding CPU in it, so it will be perfect for testing. It's a Phenom X495 something, I think. So it's a 125-watt CPU, so it will be perfect for load testing this power supply. CPU showing 120 watts. 0.3 volts is stable. 5 volts.